In this video, we will demonstrate the functionality of the Cloud Notes desktop application. We have already started the servers and have reviewed their logs in the previous video. Now we will start the Cloud Notes application. It displays the splash screen while logging into the RESTful Service Provider. Here we can see that it successfully logged into the RESTful Service Provider. The buttons below allow us to display the About screen, the Connection Settings window, and the Register New User window. The Connection Settings window allows users to select from a list of discovered consumer provider configurations. We can see that it has discovered a communication bus provider and a RESTful service provider. Selecting one of the communication provider configurations will cause the user interface below to be dynamically created using the information from the selected consumer provider configuration. To learn more about the consumer provider configuration files and the dynamically generated user interfaces, see the Servers Overview video. To learn more about dodSON WPF editors, see the dodSON core library, dodSON WPF namespaces. Next, we will attempt to connect to the communication bus provider. Watch the Relay server to see the Cloud Notes consumer client connect directly to the Relay server's communication bus. Now we will switch back to the RESTful Service Provider. We can see that the Cloud Notes consumer has disconnected from the Relay server. However, the Cloud Notes consumer client will not be displayed in the list of clients connected to the RESTful Service server because that list is for clients connected to the server through the communication bus. The RESTful Service Provider has instead connected to the hosted HTTP RESTful service. Looking at the registration server's registration service plugins custom configuration file, we can see that the registration provider group has been designated to use the file registration provider. The file registration provider will use a comma-separated values file to store user registration information. Here we can see that the file does not yet exist. First, we will attempt to log in. This will fail because there is no registered user by this name. In fact, there are no registered users. Therefore, we must register a new user. Once the new user is registered, we will reload the file registration comma-separated values file where we can see the newly registered user security information. This includes the password hash algorithm, password salted hash, and the password salt. A salted password protects the actual password while providing mechanisms to validate candidate passwords. See the Programming with the dodSON Core Cryptography Namespace video for more information about salted passwords. Looking at the Note Server's Note Service Plugins custom configuration file, we can see that the Notes Provider group has been designated to use the File Notes Provider. This Notes Provider will use a comma-separated values file to store user notes. Here we can see that the file does not yet exist. Returning to the Cloud Notes application, we can see the Notes window displays the current connection type, the currently logged in user, and the number of notes in the list. Pressing the Add Note button will display the Add Note window. The Add Note window will let you edit the title and the text of the note and then save the note. This window also displays the current connection type and the currently logged in user. Now we will add our first note. Saving the note will return us to the Notes window, where we retrieve all the notes for the currently logged in user and display them. Looking at the File Notes comma-separated values file shows the newly added note. Next, we will edit the note and save it again. Reloading the File Notes comma-separated values file shows the note has been edited. Now let's add a few more notes. Again, we can see that the file notes, separated values file has all the new notes. If we delete a note and reload the file notes, separated values file, we can see that the note was indeed deleted. Now we will exit the application and shut down some of the servers. We will first modify the registration server's registration service plugins custom configuration file to use the SQLite Database registration provider, which will use a SQLite database to store user registration information. Then we will modify the Note Server's Note Service Plugins custom configuration file to use the SQLite Database Notes provider, which will use a SQLite database to store user notes. And then we will restart each of the servers. You can see as each server is started, its bridge shows up on the Relay server's list of clients. Once all the servers have started, we will start the Cloud Notes application. We'll need to register a new user because there is no database, therefore there are no registered users. Successfully registering a new user will cause the Cloud Notes application to attempt to load all the notes for that user. The SQLite Database Notes provider will create an empty database when it attempts to load notes. Returning to the Cloud Notes application, we can see the Notes window displays the current connection type, the currently logged in user, and the number of notes in the list. Next, we will add a few notes. Before we leave this window, let me demonstrate that we can sort the notes by title and last modified date. This window was the only window that had extra code in its user interface code behind. That code is what makes sorting and displaying the direction arrows possible. Next, we will log out and change our connection type to directly connect to the Relay server using the communication bus provider. Watch the Relay server to see the Cloud Notes consumer client connect directly to the Relay server's communication bus. Once connected, we will log back in and see the Notes window display the current connection type, the currently logged in user, the notes we just added, and the number of notes in the list. Now we will start Visual Studio 2019 and use the SQLite SQL Server Compact Toolbox to connect to the registration database. We can see it contains a single table called User, and that table contains a single row containing our user's security information. Next, we will connect to the Notes database. We can see that it contains two tables, a user table and a notes table, and that the tables contain the proper information. The username is what connects the registration database with the notes database, and the user ID is the foreign key used to connect the users table and the notes table in the notes database. Next, we will edit a note and show that the edited note was updated in the notes database. We will also delete a note to demonstrate that the note was deleted from the database. We have demonstrated here that the Cloud Notes application works using either the directly connected communication bus provider or the RESTful service, and that the registration server and the Notes server can work with either the comma-separated values file provider or the SQLite Database provider. Now let's shut down the Cloud Notes application and the servers and examine the logs. We will start with the Cloud Notes application log. We observe that the Cloud Notes application has started and that it has installed the Consumer Communication Bus Provider package and the Consumer RESTful Service Provider package. Next, it will search for provider configurations. It displays that it found two provider configurations, the Communication Bus Provider and the RESTful Service Provider. Since the RESTful Service Provider is the currently designated consumer provider in the Cloud Notes application configuration, the Cloud Notes application will attempt to log into the RESTful Service Provider. Looking at the RESTful Service Services log, we can see that the Server Bridge plugin was started and the RESTful Service plugin was started along with its HTTP RESTful service. See the server's overview video in this series for detailed information about the servers and their logs. We can see that a login request was received from the Cloud Notes consumer. This starts a handshaking sequence that creates an encrypted tunnel where the Cloud Notes consumer will pass its login evidence and the RESTful service will pass back encryption and compression information. Because the Cloud Notes consumer has the proper evidence, it will successfully log in to the RESTful service, which will be logged in the Cloud Notes consumer and RESTful service logs. Next, we will register a new user. The Cloud Notes application will send a register user request over the HTTP RESTful service channel to the RESTful service server, which will send the request on the communication bus directly to the Notes server. The Notes server will send the request directly to the cache registration service. Since the cache registration service cannot register a new user, it will send the request directly to the registration server. The registration server receives the register user request and registers a new user using its initiated registration provider. The registration server sends a success message directly back to the cache registration service, which sends a success message directly back to the Notes server, which sends a success message directly back to the RESTful service server, which finally sends a success message over the HTTP RESTful service channel back to the Cloud Notes application. It should be noted here that the Cloud Note application automatically broadcasts a Notes request to retrieve all the notes that belong to a user so it can display them in the Notes window. It does not log this request. The Cloud Note application sends the Notes request to the RESTful service server, which sends it to the Notes server, which will first validate the user's security information by sending a validate user request to the cache registration service. The cache registration service has cached the user's security information and can validate the user without communicating with the registration server. On successful validation, the Notes server will assemble all of the note headers for the specified user and return them to the RESTful service server, which will return them to the Cloud Notes application, which will display them in the Notes window. Next, we will add a new note. the Cloud Notes application will send an add note request to the RESTful service server, which will send the request to the Notes server. The Notes server will first validate the user's security information by sending a validate user request to the cache registration service. The cache registration service has cached the user's security information and can validate the user without communicating with the registration server. On successful validation, the Notes server will add the new note using the instantiated Notes provider and send an add note response back to the RESTful service server, which will send the response back to the Cloud Notes application. This will, of course, cause the Notes server to automatically broadcast a Notes request to retrieve all the notes that belong to the logged in user and display them in the Notes window. These interactions continue in the same fashion for all other requests. Next, we can see that we log in to the communication bus provider, which logs us out of the RESTful service provider. Then we proceed to get notes, edit a note, and delete a note just like before. To view this code and these logs in detail, download the Software Development Kit code help file zip file. This zip file contains a detailed help file, all of the code seen in these videos, and all of the configuration files, packages, and logs used and created in these videos.